Yes, sir.
So which one is the
Newton's second law, sir.
any particular question?
It's coming for the derivation, sir.
Which one?
Those Newton's second law.
Then second law says the force is rate of change of momentum. That is the starting point. Okay.
Okay.
So, and you know what is momentum?
Yes, sir.
Momentum is what?
Momentum is the what is
Mass
it?
into?
Mass into force, sir.
No.
Huh.
Mass into velocity.
Okay.
Momentum is mass into velocity, right?
Yes, sir.
Okay, so it's m into v. Okay, and force is rate of change of momentum. Okay, and momentum. So that rate of change means how fast it's changing with time. So it's change in momentum by time.
Okay.
Rate means how fast it is changing. That's with respect to time. So change in momentum by the corresponding time taken for that change. So suppose momentum is changing from 5 to 10 in 2 seconds. So the amount of change is 10 minus 5 and the time taken is 2. So 10 minus 5, that is a change by 2 is rate of change of momentum. So this is the final momentum. Change is always
Okay.
final minus initial. Final velocity is v, initial velocity is
Okay.
u. So this is changing momentum divided by the time. Okay, so this proportional. So we can have a proportionality constant that is some number k. Okay. And v minus u by t is nothing but acceleration.
Okay.
There is a definition of acceleration. How fast the velocity is changing. So final velocity minus initial velocity by the time taken for the change. So it's in and it turns out that k is 1 in SI units.
Okay.
We said in all system of units. Okay, fine. Okay, so this is the starting point. See, his law means you can only verify the experiment. You cannot question that. It's a law, right? So the law says
Yes, sir.
force acting on a body is directly proportional to rate of change of linear momentum of the
Okay.
body. Change of momentum takes place in the direction of the force. Okay. So basically, this is the starting point. Force is proportional to change of momentum. And then you use the what is momentum means. Momentum is mass into velocity. Okay. So change in momentum is final momentum minus initial momentum. That is the change. And how much time it takes for that change. That is the rate of change.
Okay, sir.
And this constant proportionality is 1. Okay. And then v minus u by t is acceleration. Definition of acceleration, right? How fast the velocity is changing. Again, this rate of change of velocity. So change the velocity by the time taken for that change.
Okay, sir.
That's it.
Okay.
And this unit of this force is mass and acceleration, right? So mass is unit is SI unit is kg, and acceleration SI unit is meter per second square.
Meter per second. Okay.
So this whole thing, I can introduce a new combined unit like Newton. So this full combination may represent as Newton. So force
Okay.
5 kg meter per second square. Instead of writing that, I can just write 5 Newton.
Okay, sir.
Okay.
Hmm.
So 1 Newton is same as 1 kg meter per second square. Instead of writing this big thing, just
Hmm.
introduce the short notation Newton.
Hmm.
SI unit is dyne. It just mass will be in grams and meter will be in centimeter, and length will be in meter, centimeter, and time is second. Okay. So because of that, 1 kg, if I convert this thing, it will be more by a factor of 1,000 kg to gram. And
Okay.
meter, centimeter, meter if I convert to, I'll get a factor of 100.
Hmm.
Because meter, if I convert to smaller unit, it become 100, right? Like 1 rupee is 100 paisa.
Hmm.
When you convert something to smaller, it will become larger. So 1 kg, if I convert to grams, it will become 1,000 more. Okay. And
Okay.
meter, if I convert to centimeter, which is smaller unit, I'll get 100 more. So total, so its product, it will be 10 raised to times 5 times more. So dyne is small unit and Newton is this big, one
Bigger.
this is one dyne. Okay. So
Hmm.
multiply this by 10 raised to 5. If you take 10 raised to 5 dynes, it will match with 1 Newton.
Okay.
That comes from this conversion. Kg to gram conversion, I'll get a factor of 1,000. And then meter to centimeter conversion, I get a factor of 100. So it's a product. So the total factor is 10 raised to 5. So dyne
Okay.
is a small unit.
Uh,
Yeah. 10 raised to 5 dynes will contribute to is equal to 1 Newton.
hmm. Okay, sir.
Okay, anything else? Impulse is
Um.
just change the momentum.
Hmm. Hmm.
Okay, so impulse by time is some sense force. Okay,
So and also the principle of that momentum, linear momentum.
conservation.
Yes, sir.
Yeah, suppose there is no, suppose a body is moving
Hmm.
a particular m and particular velocity v. Okay, suppose the v is towards right, it will continue to move if there is no force acting on this one.
Okay.
Okay, so in that sense, the momentum of this thing is conserved. Okay, momentum is mass to velocity, right? How will the velocity change? If there is a friction here, right? So assume this is ice surface, and this is also very smooth. So in that case, friction is approximately zero. That means V is approximately constant. In this case, the momentum of this block will not change. So from this, you can guess the principle that if external force
Hmm.
is zero, if then momentum
Hmm.
P is conserved. Conserving does not change.
Hmm.
Okay.
Okay.
That is the statement of conservation momentum.
Hmm.
Uh, See, in absence of external force, okay,
Okay.
this is a combination. Okay, here he's taking instead of taking single mass, he's taking two masses. Okay, so the two masses is my system. So here he's saying sum of momenta, the moment of the system after collision equal to before collision. So here I took a single mass. Right? Here you can also take two masses. Okay, A and B moving
Hmm.
towards U1 and U2. Okay, so they are colliding. Okay, after collision, the velocity will change in general. But if you do this initial mode of the system, which is M1, U1
Hmm.
plus M2 and U2, and this final momentum M1, V1 plus M2, V2. These two are equal because there is no external force, because there is no friction here. The only force is when they are colliding, there will be interchange of some contact force will be there. But there's an internal force between A and B. If you take A and B as a system, that the force during collision, that's between A and B, right? It's not between uh, this and outside. Understood, right? A and B is my system. This is my
Okay.
system. Okay.
Hmm.
So there is no friction here on the surface. The only force is while colliding, but that's the internal force between A and B. A and B are within the system, right? Not outside. Okay. So in this case, the external force is zero.
Okay, sir.
External force. Okay. So external force is just the amount of the system is conserved. Initial amount of the system is M1 E1 plus this one. That's equal to M2. And okay. And here, this force is because the impact force. So the whatever force exerts on one and the other, it's same as the force exerted by the other on this one. Okay. So whatever
Okay.
this interaction force, uh,
Hmm.
the force acting on this one, M1 is FB.
Okay.
Force acting on this B is
Hmm.
uh, force acting on B is FA. Okay. So force acting on B is FA, and that's changing the momentum of this second one. So force on B will go and change the momentum of B. That changing momentum is this one. That's and this force comes from FA, from A. So it's called FA. Okay. Slight confusion is here. This force on B due to A. This is the source of the force. So he has put the source of the force here. Who is experiencing the force? B.
Hmm.
Okay. Similarly, force on, so this is the source of the force at B. So he has put the name of the force as source as the force, but it's acting on A. So it's changing the momentum of A. Okay. So these two forces are equal in opposite direction. So minus sign is required. Okay, because forces are vector, force has got a direction, right? If I push to
Yes, sir.
the object will move towards right. If I push towards the left, the object will move to the left. So direction makes sense.
Hmm.
Force is a vector. So because of that, this minus sign is required because FA,
Hmm.
FB is towards left, FA is towards right. So magnetic
Hmm.
is same, their direction is opposite. So one direction I take it as positive, other direction is negative. So I put a negative sign. So from this I'll get this one.
Ah.
So in some sense, this conservation momentum is proved using Newton's third law. This third law, right? This one. Newton's third law. Using that, I'm proving conservation of momentum.
Yeah. Yes, sir.
Conservation momentum is proved using Newton's third law. So take two objects or two balls A and B. Okay. So the only force acting on this one is the interaction force or force during collision.
Okay, sir.
Fa is acting on B. So that will change the momentum of B. So that
Hmm.
force Fa, this one, second one.
Okay.
Sorry, this one only. Fa, that will change the momentum of B.
Hmm.
Okay, the radiation moment. Similarly, Fa acting on B, due to B acting on A, is on A due to B gets on B due to A. So the force is A.
Okay, sir.
Hmm. Anything else?
No, sir. So can we see the equation in this lesson, sir?
Which equation?
In this lesson, the problem, so solve the problem.
Which one you want? You have doubts in any particular problem or
No, sir, any not particular topic.
by now you should solve everything, right?
Yes, sir.
Hmm.
Actually, I solved the problems in exercise. Sorry, in electricity,
Hmm.
um, acoustics, and optics.
Okay, so have you solved this one? First one?
No, sir, I have to see. I have to see
There.
this
Okay,
lesson.
just try now. Try now. It's not difficult.
Okay, sir. 1 second, let me take.
As soon as you read the question, convert the information in terms of symbols. Like this one, you understood, right? Two bodies, mass ratio is 3 by 4. So as soon as you read this, write this one. M1 by M2 is 3 by 4. Okay, once you write this, you don't have to read this thing again. So this means E1 is 12. Correct? No. Or bigger mass. Okay, it's A2. Bigger mass is the second one.
So can you repeat it?
The two bodies, mass ratio 3 by 4, right? So M1 by M2 is 3 by 4. So which mass is big then? M1 or 1 or 2?
M2, sir.
Ah, and then he's saying bigger mass produces
Hmm.
acceleration of 12. Okay, so
12.
it means A2 is 12.
Hmm.
Force applied on bigger mass produces acceleration of 12. So A2 is 12. So what is the acceleration
Hmm.
of the body? The same force acting on. So now we have to find A1.
Hmm.
If that same force is acting on this one.
Hmm.
What is the answer?
1 second, sir. Sir, the answer is for A1. 16, sir.
See, first you can find the force which is M2 into
Uh,
A2. And this is the same
yes,
force
sir.
acting on this first one also, it's M1 A1, right? These
Yes,
two
sir.
equal. So from this I can get A1 as M1 by M2 into A2. M1 by M2 is 3 by 4 into A2 is 12. So it's 9. What did you get?
Sir, for the A1, I get 16, sir.
No, no.
Um, for the
Oh, sorry, sorry.
4.
Did I make a mistake?
Okay.
Same force acting on the small one. A1 should be bigger. M1 by M2.
I will talk with you.
So sorry, I made a mistake here. See, M2 by M1. Yeah, I think you're correct.
Yeah.
See, the smaller mass will move fast. Acceleration should be the move for smaller mass.
Hmm.
A1 is M2 A2
Hmm.
by M1. Okay. M2 by M1 is 4 by 3. Into
Yes, sir.
A2 is 12. It's correct. 16. Okay, same force. If mass is more means acceleration will be less. M2 is more. So
Yes.
A1 should be more than A2. So it should be more than 12 and it is 16. Is it clear?
Yes, sir.
Now do the second one. Draw a figure as soon as you read the question. All the information in the question should come in the figure.
Okay. Right. ஒண்ணு சொன்னாங்கம்மா ஒண்ணு சொன்னாங்க நானே வந்து பேசுறேன் நீ அது பண்ண நீ இப்படி பண்ண பரவாயில்ல பாட்டு சொல்லி அதுக்கு So can the answer come in negative?
Yeah, that depends on your choice of what you choose as positive direction.
Okay.
According to your choice, and then that sign can be interpreted as a thing. Suppose if you get negative means you've chosen the downward direction as positive. Okay, so that means what was the number? Direction is upwards.
Okay.
See here, if you choose the upward direction as positive, then initial moment is minus 1 into 10.
Yes, sir.
Right steps initial, okay.
Yes, sir.
And then
So
final
we'll
moment
be
is
getting
1 into 10.
10.
So now the
Yeah.
change delta IP is plus 20 with the upper direction. So this means it's 20. The sign I can write as upwards.
Okay.
So if you choose the other way, then it is minus 20, but still it should be upwards.
Okay.
The final upward should be correct. Okay, third one.
So for this formula is L2 is equal to F1 into L1 by L2. So sorry, F2. Is it the
It's
formula is
okay.
correct?
Remembering big formulas, you can say the torque required to open that, unscrew that nut is 140 into 40 in SI units. So it's 40 by 100. That much Newton meter. So this is the torque required to unscrew that nut. Okay. So
Okay.
this torque now should come from spanner of length.
Okay.
What was the length of the spanner? And the force I'm applying is 40 Newton. Okay. I should get the same torque. So 140 Newton, the length of the thing is this one. So these two are equal. So from this I'll get length is 40 and 40 will cancel 100, 1.4 meter. So it's 140 centimeter. So if you want to apply a small force and open that same thing, I need a bigger lever or bigger length. Check the answer.
1 second, sir. So that's 1.4 meters, sir.
1.4 meters, same as 140 centimeters.
Okay.
So the first step is torque required to unscrew the nut. That is the 140 into 40 centimeter. What is we have to convert to meter because SI units. Okay, so that torque should match now with the 40 Newton to new length.
Okay.
Okay, so 40 and 40 will cancel. So 140 by 100. So 1.4 meter. Fourth question.
So can you teach me the first question, sir?
Sorry,
Can you teach me the fourth question, sir?
it's gravitation.
Ah.
Gravitation theory part, you know.
Mm,
If you have two
yes.
masses, the force between them is what?
1 second.
We should know the formula by now. M1, M2 by
For
Newton's law of gravitation, right? G,
it's, G is
M1.
equal to GM by R square.
Is this correct? This one. G is constant. Okay, M1, M2 by M1 plus 2. This means if the mass is more, so force will be more. Okay, and also the
Okay.
distance is more means the force will decrease. Okay, so here, two masses of planets. Here, okay, here there is planet 1 and second planet.
But in the exam lesson, they have given some other formula, sir.
No, that's what you don't should not apply formula directive. You should understand the
Okay.
formula, right?
Yes, sir.
So just okay. Then let the two planets be M1 and M2. I'll come to the formula later. First understand. Okay.
Okay.
So acceleration of gravity means what? G, right?
Yes, sir.
G is force on unit mass,
Yes, sir.
right? So if you have M1, if you put 1 kg here, force on this one is G M1 by whatever this distance. That distance is actually, see, this mass is actually on the surface. So the distance between this M1 and this 1 kg is the radius of this M1. So GM1 by R1 square. Okay, similarly, put 1 kg on the surface of this one. The force on that will be GM2 by R2 square because it's GM1 second mass, but the second mass here is 1 kg. So the second mass is 1 kg. That is definition of G, right? So this
Yes, sir.
G1, small g1, this small g2. Small g is force on unit mass due to the source mass. Okay, so the first one, the source mass is m1, and there is 1 kg on the surface. Distance between these two is the radius of this m1, say r1. Second planet, again I put a 1 kg on the surface. Source is m2. So force on this 1 kg due to the source m2 is gm2 by r2 square. R2 is this radius of this one. Understood? So these two, you have to find the ratio of this g1 by g2. Okay, so g1 by g2, capital G will cancel. It's m1 by m2 into r2 by r1 square. Is that clear?
Yes, sir.
G is directly proportional to m, but it's inversely proportional to radius square. So that's why 2 will come up, 1 will go down. m1 by m2 is given. Mass ratio 2 by 3. And radius ratio is 4 by 7. So it will become 7 by 4. Okay, so this is
Okay.
7 square is 49 by 4 square is 16. And then 2 will cancel, so it's 8. So 49 by 8 is 24. So it is 2, it's equal to 2 plus 1 by 24. It's approximately 2.
Okay.
Check the answer. 24 is 48. What is the answer?
For the G1 is 49, I think so. For
No,
the
no, just
G1
the
is
ratio, right? You don't have to
yes, sir.
find the ratio. That's why you don't have to
Mm.
calculate and all. Do the
Hmm.
calculation in the end then.
Hmm.
It is 2.
Yes, sir. It's
What
coming
is
as
that?
2.
What is the answer?
It's coming as 2, sir.
No, no, book answer.
Um, book answer they just have given that G1 is equal to 49 and G2 is equal to 24, sir. That's how they have given.
No, so 49 by 24 is 2 only. Approximately 2. Oh, they are given, they
Okay.
stopped here.
Yes, sir. They stopped in the ratio itself, sir.
Okay, fine. That's also correct.
Mm.
You can also write like this 2 plus 1 by 24.
Mm.
That has got better meaning, right? I mean, it makes more sense. And you can write approximately 2. Okay, so Newton's law says this one, force between two masses. But here it's not like this, it's like
Mm.
this. M1 and M2, there is no relation. The relation is between M1 and 1 kg and M2 and 1 kg. Okay, that's why you have to understand the formula and use it, not just use it blindly. Okay,
Mm.
and acceleration to gravity is G, which is force on unit mass. That's force by mass.
Okay.
Okay, that's same as putting the second mass as 1.
Mm.
Clear?
Okay, sir.
This one again will test in a student's first law. See, whenever you match, you just read all the 4 and then see which is most appropriate. And also you have to read all these 4 and then see which one is most appropriate. Because sometimes it will not be very clear, but what is the best answer you can give? Newton's first law, Newton's second law,
Mm.
law of force, right?
Yes, sir.
Newton's third law is action and opposite reaction.
Every
Yeah.
action has
No, no.
opposite and
See, the fourth option is better. That's why I
mm.
said I will read all the 4. Conservation of momentum, this one. Third law is first law is stable equilibrium of the body because there's no force means it will be at rest.
Yes, sir.
Third law, propulsion, flying nature of bird. It's
Mm.
not clear. Ah, flying nature of bird. It's okay, you can relate this one because the wing of the bird will push on the air, right? And the air will push the wing upwards.
Mm.
When the bird is flying, the bird will flap the wing, so the wing is pushing the air down. So reaction is air will push the wing upwards. So that's why it's staying above.
Okay.
Okay, check the answer.
Mm. So for the first one is stable equilibrium of body,
Hmm,
and for the second one is law of force,
okay.
and third one is flying a natural bird.
Hmm. Yeah, that's what
Next,
I did.
law of then it's rocket proportional, sir.
See, in rocket,
Hmm.
there is huge amount of fuel here. Okay, when the
Hmm.
fuel burns, it comes out, right? So some part of the mass is coming this way. Okay, so this capital M should move with the velocity upwards. See, initially when it's at rest, the momentum is 0
Hmm.
because everything is at rest, right?
Yes, sir.
Okay, so when this thing comes out this way, because the momentum of this is 5 units, the momentum of this
Hmm.
thing should also be 5, but maybe minus 5 because the direction is opposite. Momentum is a vector, right?
Yes, sir.
Because velocity is a vector. Okay, so this fuel that is burning will come down, will be pushed
Hmm.
down. Okay, so the rocket will move up. So the momentum of these two are opposite. So the momentum of this fuel is m into v. That's equal to the mass of the rocket, which is high, and the velocity is small v, the velocity will be v. Okay, so this is one first step. The next step again, another m will come, and this m will act on this m minus m. Why it become m minus m? Because the fuel has come out, right? The initial mass m is that uh, mass of the full rocket with the fuel. But once this
Hmm.
fuel has come out, then the next step will act on a smaller mass.
Hmm.
So this mass of this rocket will keep on increasing as it keeps burning more and more fuel.
Hmm.
So that's why it'll pick up velocity. You will derive that thing, right?
Yes, sir.
Rocket propulsion. You not, is it?
Hmm.
They are not derived it. Okay, then propulsion is based on conservation of rockets are
Hmm.
fuel is burned, hot gas is ejected with high speed from the nozzle, producing huge momentum, balances momentum, equal and opposite force is particular condition which makes them rocket project rise in motion as the rocket gradually decreases. That's what I said. From m it becomes m minus m until the fuel is completely burned out. Okay, understood?
Yes, sir.
They explain as a theory thing, but that is
Hmm.
what I explained. This one first one, inertia of a body depends on what? Weight, acceleration, mass, both A and B.
Mass of the object.
Which option?
Mass of the object.
Yeah. Impulse is what?
Change of momentum.
Yeah. Newton's law applicable to
For a body at rest, and for body in motion. Both the options.
momentum on y-axis and time on